Hello. So let's discuss some 10 problem on dynamic programming. So let's see. So our target is to finish 10 question on dynamic programming. It is an important in every technical interviews. So 10 important DP problems. So let's see. The based on first question based on LCS, longest longest common subsequence. Okay, longest common subsequences. So let's let's see. So what the question states us. mm, in our question given that we have we have given given we have two string s1 and s2. Okay, s1 and s2 are given. The task is to find the length of the common subsequence. If there is no common subsequence, return 0. A subsequence is a string that generated from the original string by deleting 0 or more characters without changing its relative position. So we understand the basic of subsequence. Subsequence mean, like example, we have string s is equal to a, b, c, d. Okay, mean we have to delete one or more than one element, but maintaining the original sequence. So a, b, d is subsequence. A, c, d is subsequence. B, B, D is a subsequence because the order is maintained. Okay, and subsequence is a string generated from the original string by deleting the 0 or more character without changing its relative order and remaining in character. For example, ABC, A is subsequence, B is subsequence, C, D, A, B, ABC. So in general, the string of length n has a to the power n subsequence. Simple formula: string of length is n, then the subsequence is equal to the power to the power n. Subsequence will be generated from that string. Okay, okay. The question is based on common longest common subsequence. S1 is given as a b, c, and S2 is given as a, c, d. Okay, ACD. The longest common subsequence in S1 we see that A, C, and in S2 we see AC. Longest common subsequence of length 2. Okay. If there is no subsequence, we have to return in return 0. Okay. What we have to do? So let's see. Mm, what are the approach we think by solving? Recursively, we check every element. If they're common, then return. So checking recursively means to the power the minimum between m or n. Okay, and time complexity also greater than. So let's see why our recursive intuition is failed. So first method is solve using recursion. Okay, through recursion, what are the problem arises? So in recursion, steps are so first of all, match in the idea is to compare the character of S1 and S2 while comparing the idea is to compare the last character of S1 and S2 while comparing the S1 and S2 two cases. If match, make the recursion call for the remaining string for m-1 and -1, add 1 to the result. If do not match, make two recursive call. First, the length on m minus 1 and n, and second is m or n minus 1, and take the maximum of two result. If any of the string become empty, return with 0. Okay, so let's write the code. Int LCS, and we have to find given string given string s1, s2 is given. Okay, okay, what we do, if m is equal to 0 or n is equal to 0, this means that the length of any of the string is 0, so there is no common subsequence, so return 0. Okay, after that, if s of m minus 1 is equal to s2 of n minus 1 n minus 1, if both are equal, then we have to return 1 plus and search for next, search for remaining character. So same LCS in which we have length s1, s2, m minus 1 or n minus 1. Okay, if this condition is satisfied, if this condition is not satisfied, if this condition is not satisfied, else case, what we have to do, simply return max of what, max of LCS, in which s1, s2, and keeping one character is constant, and move the other character in string 2 string 2 string 1 string 2. Okay, so in this case, one s1 m is constant, and move the n1, and LCS similarly for the another one, LCS s1 comma s2, and m minus 1 or n remain constant. So this one is the case. So max of this is the answer. So the what we write in the main function for calling, in main function we have to initialize the size m and n. Okay, and the return function for the LCS s1 given, s2 given, size of each uh, word is given. Okay, so this approach give the longest common subsequence using recursive approach. Okay, the recursive approach lead to a TLE because we do not store, we use repeated loops, repeated data inside it. There is some overlapping problem inside it, so we have to memorize. So starting memorization technique, for the memorization we have to create a 2D and 2D DP. The two things are changing, index on S1 or index on S2, so we have to use 2D DP. Okay, for 2D DP we have to create, let's see what are the similar part, remaining all similar parts as well. This one the code we are solving for the memoization. Okay, for the memoization we are solving. So in main function we have to make a 2D vector, because we are int vector of int of dp. Okay, dp of size what, m plus 1, keep the size 1 given, vector of int of n plus 1, all initialized with the -1, all initialized with the -1 value. So 2D vector is defined for the storing all the values. We have to pass dp inside this dp vector 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 integrate memo. Okay, so here we have to do this. If condition, if dp of m dp of m is not is equal to -1. In this case, we already stored that value. We have simply written the dp of m dp of n. Okay, or we have to store this value. We can dp of m is equal to n. Okay, or in this case also, if this case satisfied, or in this case also, we have to write also have is equal to. Okay, this is approach. This is memorization approach. In this case, the really is not happening. After that, we move for the bottom up approach. In bottom up approach, we simply approach tabulation. Time complexity become m cross n. Time complexity become m into n. So then column are traversing. In bottom up approach, same thing happen, but we simply first of all we find the size of the S1 and S2, initialize a matrix of m plus 1 plus n plus 1 size matrix, initializing all the value with the 0, run a for loop, int I, starting from the int I 1 to m and j from 1 to n. If both of element are matching, then we have to return dp of I, dp of j is equal to 1 plus 1 less than 1 plus value, else we have to find the maximum between their differences, and in last we have to return dp of m into n. So dp contain the length of LCS for the S1 0 to n minus 1 and S2 is equal to 0 to n minus 1. Okay, so the first question of dynamic programming is covered for the longest common subsequence. So let's move forward for the next important question is longest increasing subsequences. Okay, longest longest increasing subsequences. Okay, longest increasing subsequences. So what this question explain us? Okay, let's see. So longest common subsequences in which we are given an array given things like given an array of in which value are 3 comma 10 comma 3 comma 10 comma 2 comma 1 comma 20. We have to find the longest increasing subsequences. So longest increasing, we see the value 10 increasing subsequences are 3, skip the, and take 10 value, skip 2 because it's less 1 less, so 20. So length is equal to 3 length 3 length and increasing subsequences. So simple one. As we know that we recursively solve the one problem and move forward for the next problem. The idea is to traverse the input array from the left to right. Find the length of the longest increasing subsequences ending with the verify. Let let us find the length of this. At the end, we have to return the max length of L of I. So we use recursion. We consider the smaller element on the left of the AR of I. So recursively compute LIS longest increasing the value or smaller on the left, take the maximum value of all and add 1. If there is no smaller value on the left, return 1. Okay, if L of I is the length of alias ending at the I, such as array is the last element of alias. So formally finding, let us code what we have to do. Alias code. Alias is taking, not taking. The idea is to take or not take. Okay. Idea is to take or not take. So in every element we have to take or not. This is a DP generic approach. So let's see recursive approach. Recursive, recursive approach. So recursive approach, we have to write the code for this. So when we have to find the longest increasing subsequence, int lis longest, in this what is given? Our idx is given, index idx, and the previous index is also given. Lis given and num is provided. So first of all we have to check base condition. If our idx reach to the nums dot size, this means that we reach the end, so we have to return 0. Okay, just return 0. So after that, either we have two choices, take or not take. Taking and not taking have both condition. If we start, if we don't take any element, so not take means this step simply with alias, all things are same. Alias simply idx plus 1, previous index will be same and nums will be same. Okay, when we have to take initialize with 0, taking condition will be if previous index is equal to -1 or nums of idx is greater than nums of previous index. Nums of previous index, then in this condition we have to take that element. So taking means increasing the length, so 1 plus a move for the recursive solution. In this idx is increased by 1 and the previous become idx and nums. Okay, this is the condition, and we have to find the maximum value. So if true maximum, take or not take condition. Okay, this is the approach we use. Okay, this is the recursive approach. We have to memorize. So simply in memorization technique we have to create what is changing. So two things is changing where index and previous element. So we have to use a dynamic. So in main function in recursive approach, and in we have to write memo code in which all the things are same, just simply adding the memorization technique. Control C. Simply in main function, in main function, simply where all the things happen, and equal to num dot size all are given, or the function are calling like return lis having idx starting with a 0 minus 1 previous or nums is that is given. But for the memorization technique, we simply add a vector to the vector because two things are changing, idx or previous. So vector of int name as dp. dp dp of size was same matrix now. Size will be same. So vector n plus 1 minus 1. So we created the 2D vector. So in this main function, pass in main function. So here we have to also pass dp and check the condition. Check the condition. If dp of idx, the dp of idx or previous plus 1 index is not is equal to minus 1. This means that they are already searched and already stored in value. So in this case, we have to return dp of idx or previous of plus 1, or in this case we are taking store the value dp of I dx. We have to store the value. So so there is no need to put take and not take. So in simply at the end we have to initialize dp of idx plus previous plus 1 index is equal to max of this. So this is the memorization technique. Through the TLE condition will be resolved. So this the time complexity of this approach. In this time complexity, in this condition, time complexity is order of to the power n, to the power n. Okay. Every element we have two choice. So, but after memorizing, we reach to the solution. Solve in order of big of n into n square. Okay. Bottom approach simply in bottom up approach. And bottom up approach, there is simple approach. So let's write bottom up approach. Yeah. Bottom approach simply what we have done, int n is equal to nums dot size, nums dot size, or we have to create a vector so in which the length is stored till this position. So dp of size n minus n is equal to 1. Okay. Into max c is equal to max length is equal to max is equal to 1. For loop int starting from 0 I less than n I plus plus two loop is running now. For the previous, we have for previous and previous and previous index is equal to starting from 0 and uh, previous ending with less than n. Okay, like this I plus plus or previous plus plus. If n of I, if the condition is if our nums of I is greater than nums of previous, in this case we take so we store the value of dp of I is equal to maximum what maximum dp of I comma 1 plus dp of previous. Okay, and at the last, after for loop completing, else case condition is max c is equal to max of max c and comma dp of I, and final result will be final then return the max c. This will be the bottom tabulation. This is on the bottom up tabulation, top down. So all three condition for the recursive memorization and the tabulation method through which all the codes are written. So So take a break for 20 minutes and we again join the session.